All right, the second way that we solve linear systems is through an approach that we call elimination. In a different video, I showed you how to solve them using substitution. The second way is elimination. So let me write an equation for you. 2x plus 6y equals 17, and 2x minus 10y equals 9. Okay, so here are two equations, and we're going to solve this. Notice how the coefficient is not 1 here, it's not a 1 here, it's not a 1 here, and it's not a 1 here. That makes it a perfect candidate for elimination. You don't want to do substitution with this, because to solve it for x equals or y equals has a lot more algebra to it than using the elimination method. And the elimination method basically says this: find a way to cancel out either the x's or the y's. And you can do that by multiplying one or both equations by any number you want. Because as long as you multiply the left side and the right side by the same number, okay, you haven't affected the equation at all. So best way to show you this is through example. So let's look at this one again. We have a 2x and a 2x. So the easiest way to eliminate the x's, okay, is to multiply one of these equations by a negative 1. And you say, well, why is that? Well, let me show you. Let me multiply this top equation by negative 1. I get negative 2x minus 6y and negative 17. Basically, the effect of multiplying this whole equation by a negative 1 makes it a negative, a negative, and a negative. And I go ahead and I'll bring my second equation over without any change to it. Now I haven't hurt my first equation because I multiplied the left side by negative 1 and the right side, so everything is still legal. But by doing that, I now add these equations together. Negative 2x and positive 2x makes the x's go away. Negative 6y and negative 10y makes negative 16y, and negative 17 and a 9 makes a negative 8. Divide by negative 16, and I get y equals a half. I now need to solve for x. And you can solve for x by putting this answer for y back in to either of the two original equations, whichever one you want. I'll pick the second one, this one. So 2x minus 10, but I'm not going to write y, because I've solved for y. So why not just plug that in for y? Okay, so I get 2x minus 5 equals 9, 2x equals 14, and I divide by 2, and I get x equals 7. So for this problem, these two lines intersect at 7, 1/2. All right. Let me do another one, just so we get the process and the technique down. Let's go with 3x minus 4y is negative 10. 6x plus 3y equals negative 42. Okay. Now, I look at these numbers. I got a 3 with a 6, and I got a 4 and a 3. Well, the easiest thing to get two of these numbers to match, and they have to just be different by a sign. By virtue of making, let's go back over here a second, by virtue of making one of these a negative and one of these a positive, when I add them, they go away. Negative 2x plus 2x is 0. So I need to create that same effect here. Well, I can make a 3 into a 6. That's easy to do by multiplying it by 2. But I'm going to multiply by negative 2, because I don't want a 6x. I want a negative 6x, so I want to cross it out with this second 6x over here. So I'll take this first equation, I'll multiply it by negative 2 to get negative 6x plus 8y equals 20. I'll bring the second equation over, and sure enough, now these go away. I get 11y equals negative 22, and I get y equals negative 2. I divide both sides by 11, so I get negative 2. Then I take that answer and I plug it into either of the two originals. I'll go ahead and pick the first. So I get 3x minus 4y. I'm not going to write y, I'm going to write negative 2 equals negative 10. 3x plus 8 equals negative 10. 3x equals, add 8 equals negative 18. And I get x equals to negative 6. So for this problem, these two lines intersect at the point negative 6, negative 2. All right, let's do one more. Let's do one where we have both equations. Okay, we'll have to multiply both equations. Let's do 4x minus 5y equals 13, and 6x plus 2y equals 48. Okay, I've got 4 and 6, 5 and 2. Well, I can't just multiply one of these equations. I can't make a 4 a 6. There's nothing I can multiply the 4 by to get a 6. And I can't make a 5 be a 2. So I have to multiply both equations by a number, different numbers, in order to get this cross out. And what I'm going to do is I'm going to look at the x's. No, actually, let me do y's this time. I did x's on the first two. If I make this be a negative 10, and I make this be a positive 10, I can get a cross out. So I take the first equation and multiply it by 2 to get my negative 10, and I'll take my second equation and multiply it by 5 to get my positive 10. So when I do that, I get 8x minus 10y equals 26, and in my lower equation, I get 30x plus 10y equals whatever 48 times 5 is. I don't have a calculator here. 48 times 5, okay, that's 40, 24, 240. Okay? So now I have my two equations, and my y's are going to cancel out. Okay, so I add my x's, 38x, these go away. 38x, 240, and 26 is 266. I divide both sides by 38. These are big numbers. And the answer here is, let's see here, 7, I think. Yes, x equals 7. 266 divided by 38 is 7. So that's my x answer. I got both of these y terms to be 10, one negative, one positive. I have my crossed out. Now I take my x equals 7, I plug it back into either of these. I'll take it into the second equation. 6x, I'm not writing x because I know what x is now. It's 7 plus 2y equals 48. 42 plus 2y equals 48. 2y equals 6, and y equals 3. So at the end, we get 7, 3 is the point of intersection for these two lines. That's how you do elimination. Good luck.